So you can actually check, you can see the attendance code for your from your chat board as well. So today's format is exactly the same as we did before. So today's topic is, I believe, is about deep learning for the biomedical imaging area. So without further ado, I give my mic to our organizers for today's webinar series. Okay. 시작하지?
Okay, we are going to start our webinar. First, we are going to introduce ourselves. Welcome everyone. I'm Gwang-Hyun Kim, an organizer of this webinar. I'm studying for a master's degree at Bioimaging, Signal Processing and Learning Laboratory.
Hello everyone, my name is Juni Kim and I am the moderator of the session 5 and I'm in the PhD course in the Sungwoong Park's professor. So I'm gonna just start it from here. So hello everyone, I'm moderator Juni Kim, and in the session 5, we will present about deep learning applications in medical imaging field. And as everyone knows, recently the field of deep learning research has made remarkable progress. And in particular, the application field related to imaging processing is more prominent. And the representative application field is the medical imaging. So today we will talk about how deep learning is advancing medical imaging processing and what are the pros and cons and current limitations and what's needed for future development. First, presenter Junior Kim will introduce the relationship between medical imaging reconstructions and deep learning on various medical imaging modalities.
Hello, my name is Junyoung Kim, and I'm the first presenter. I'm a PhD student at Professor Jong-Chul Yes Lab, whose research topic is biomedical imaging and signal processing. First, I'm going to introduce about the deep learning applications in medical imaging and give some examples. Deep learning technology has been dramatically improved last few years. Specifically, contributions in the field of computer vision for deep learning was great. This is ImageNet classification challenge, which is a challenge that competition for performance of computer classifying the images. There is an image of some categories, and computer predicts which category the image should belong to. If you see the top 5 error for the last few years, it has greatly decreased as the neural network gets deeper. Since then, deep learning has begun to be applied and studied in various fields of computer vision. For example, there are image classification, object detection, object segmentation, image style transfer, image reconstruction, super resolution, image synthesis, etc. Across these fields, deep learning has produced better results faster than conventional methods. Deep learning for medical image also started to be studied largely last few years. Since 2010, the number of papers on deep learning or machine learning has been increased. Also, not only in the research field, there is a report that world market of machine learning for medical imaging will rise rapidly for the next 5 years. Indeed, numerous companies have begun to sell products that apply deep learning to medical imaging. There are a lot of fields that deep learning can be applied in medical imaging. Among them, I'm going to talk about deep learning for medical image reconstruction especially. Medical imaging starts with obtaining data of an object from a machine. Medical image reconstruction is a series of processes from acquiring data to getting final images. The main purpose of medical image reconstruction research is to acquire high-quality medical images for clinical usage at the minimal cost and risk to the patient. First application is for MRI. When we take MR image, magnetic resonance signal is acquired in frequency domain. We can get signal in frequency domain called K-space, and then desired image is the output from inverse Fourier transform of K-space signal. However, MRI has the disadvantage that it takes a long time to obtain a signal. Therefore, many of researchers try to quickly obtain high-quality images even if the signal is undersampled. Generally, when the signal is not fully sampled, there is an artifact that disturbs the clinical diagnosis. One of the only way of deep learning application in MR image is automate. In this research, the neural network learns reconstruction of images from various kinds of sampling patterns in frequency domain signal. Unlike reconstruction from sensor to image directly, deep neural network reconstruct images both in image domain and in K-space. All these kind of deep neural networks for MR reconstruction make it possible to reduce the time to obtain high-quality MR data. Even if we take the undersampled signal to reduce the MR acquisition time, the deep neural network is well trained to reconstruct the image as sampled fully. In computed tomography, the data is acquired from X-ray projection into the object. The acquired data is called sinogram, and the desired image can be reconstructed from sinogram by filtered back projection. One of the problems of CT imaging is X-ray exposure to the patient, and repeated exposure has bad effect to the patient. Here I want to introduce some research for the CT image reconstruction that try to tackle this problem. First easy way we can think to reduce X-ray exposure is reducing X-ray dose when taking the images. However, because of physical properties, noise is generated when the X-ray dose decreases. The deep neural network solves the noise problem by translating the image with noise to clean image, and it successfully reduces the noise, which makes it possible low dose CT with high quality imaging. Next trial to reduce X-ray exposure is sparse view CT, which is acquiring data with less view. Consequently, the total amount of X-ray exposure decreases. However, there is striking noise pattern because of insufficient number of views. Deep neural network is trained to reduce the artifact at the sparse view CT image to make it clean image. In ultrasound imaging, the signal is acquired by transmitting and receiving ultrasound beam. Acquired RF data turns into ultrasound images we know after some processing. However, with a lot of sampled RF data, the power consumption of taking images or time for imaging may not be efficient. Here, the paper introduced deep learning approach to reconstruct ultrasound images using sub-sampled data instead of fully sampled data, which makes ultrasound imaging efficient. It successfully reconstructs the ultrasound image with sub-sampled data compared to other methods. So far, these are all examples of deep learning application in medical imaging I have prepared, and thank you for listening.
Okay, thank you for the great presentation, Junyoung Kim. And next presenter, Kwan-Young Kim, will talk about detailed examples of the deep learning technique applications on the medical imaging processing.
Hello, I'm today presenter Kwan-Young Kim. So the topic of my presentation is deep learning application in medical imaging about analysis and diagnosis. So firstly, I will present the introduction part, which is related to background of and main topic. So rather than first presenter Junyoung Kim focus on reconstruction medical imaging use deep learning, I will focus on analysis and diagnosis given the medical imaging. So firstly, I briefly explain about the procedure. So given the medical imaging such as CT or MRI and so on, we can utilize deep neural networks to analyze or predict the important information which is helpful for diagnosis. Then how we can conduct this? So as almost of you already know, the deep learning-based methods have achieved significant improvements on computer vision and medical imaging due to convolution neural networks, so-called CNN. So this network consists of input and output layers, and as well as multiple hidden layers. The hidden layers of CNN typically consist on series of convolution layers and followed by activation functions such as ReLU layers. In addition, CNN is subsequently followed by filling layer or fully connected layers. By this network architecture, we can more extract feature information compared to conventional algorithms. So in this slide, I will briefly explain the concept of training or test the deep neural networks. So first, given the multiple data samples, which so-called trained data sets, we train neural networks to predict the target, such as the probability of tumor or detection maps. So this procedure is called the training. And so given the new data sample, which are not included in the trained data sets, so-called test data sets, we utilize the neural networks from training phase to estimate target information. So this procedure called the test. So this pipeline of the phase of training and test is generally applied to deep learning based methods for medical imaging. So in this part, I briefly talk about medical image segmentations. So as you can see, compared to original images, so the segmented images indicate a specific region, such as the lung in the left images and brain in the right images. So medical image segmentation refers to identifying the pixels, organs, or reason for background medical images, such as CT or MRIs and so on. So to address this problem at early stage, the learning-based method were proposed for medical image segmentation. For example, statistical methods, edge detection, or filtering-based methods. However, recent breakthrough from deep learning enabled these statistical methods to be replaced with the deep neural networks. So among famous or various methods, I will introduce the well-known structural neural architecture, so-called UNet. One of the most well-known structure for medical image segmentation is UNet, is that it's built upon the FCN, so fully convolutional networks. So this architecture consists of the contracted part and extended part. In contracted part, the network is followed by repetitive two convolutional layers and max pooling. On the other hand, in the extended parts, the repetitive two deconvolution layers are followed by, and so this network architecture enables to use both local and global context information by introducing skip connections. And in this slides, I will show the result of UNet. The UNet shows the effectiveness of methods in public dataset PGC, U373 dataset, DIC HELA dataset. This dataset is microscopic dataset. So as you can see, given the input images, the unit produced a clear edge compared to LO target boundaries. So also, unit achieved an average IOU. IOU means that intersection over union. So the higher value of the IOU, the better performance. So finally, unit produced 92% or 70% on PHC or DI Stella dataset respectively. Actually, recently, significant enhanced methods were proposed for segmentation tasks compared to units, so more concrete or exact segmentation map can be obtained. And in this part, I briefly talk about medical imaging classification. So one of the main subjects for medical classification is cancer detection or tumor detection. So the goal of tumor detection is to determine whether the target image is the malignant or not. So to resolve these problems, deep learning-based methods can be applied. So in this slide, I briefly pipeline of the segmentation classification. So similar to medical segmentation, medical imaging classification had the first have a training phase or test phase. So given the whole slide images, we can obtain normal or tumor sample for trained data sets, and then we train deep neural network to predict the probability of the tumors. So at test phase, given the whole slide images, by using pre-trained networks, the deep neural networks yield the probability map of tumors. When the value of the pixel is close to 1, the corresponding region indicates a tumor region. So generally, by following this procedure, we can perform the cancer detection or classification task. So another application is X-ray chest data. So medical image classification can be also applied in X-ray chest images. So this figure shows the example of chest X-ray data sets. So the normal images shows the clear lungs without any areas or abnormal lesion in the images. However, bacterial exhibit a focal lobar consolidation, but viral shows the more diffuse pattern in first lungs. So to determine the images whether normal or bacterial or viral, the deep learning methods can be applied with various methods. So this table shows the result of the X-ray chest set from the Journal of Big Data papers. So lots of learning-based methods shows a good performance in terms of accuracy. So especially state-of-art methods at this time shows the 92% accuracy for distinguishing whether images are normal or phenomena. And recent improvements from deep learning have impact on various fields of medical imaging. So therefore we expect the deep learning leads to more enhancement of these field medical images. So this is the end of my presentation. Thank you for listening.
Okay, thank you for the great presentation, Kwan Kim. And next, the present panelists will discuss about the deep learning and the medical imaging field. First, panelist Jaegun Im will discuss about pros and cons of the deep learning application on the medical imaging.
Hello everyone. I'm Jaegun Im, and I am this bio seminar's first panelist, and I'm studying in Professor Song Hong Park's laboratory. And today I want to talk about why we use deep learning in MRI, especially pros and cons of deep learning applications in MRI. In previous presentation, presenter introduced the details about deep learning applications in medical imaging. So I, as a panelist, want to talk about the topic why we use deep learning in MRI. Please look at this graph. It is number of publications every year when we search deep learning and medical image keyword together. X-axis is published year and y-axis is the number of publications which containing deep learning and medical imaging. This research was done in 2017, so the number of 2017 is a little bit small, but we can see the number of publications related to deep learning and medical imaging are increasing over time very quickly. Then why so many researchers are using this technique in MR images? The first advantage of it is because of deep learning models processing speed and high quality, high accuracy. Radiologists can save more time and resources in segmentation or classification process. Recently, many researchers found that high-level machine learning method lead to significantly better segmentation research compared to the other simpler classification methods in stroke lesion segmentation. For example, in this example is tumor segmentation, and tumor segmentation also is a critical component of medical decision making. But because of the size of MR imaging, manual segmentation requires outlining structures slice by slice, and it's not only expensive and tedious, but also inaccurate due to human error. But with deep learning skills, in this case is CNN model, we can process this tumor segmentation process in few minutes with 80% more accuracy. And the second advantage is deep learning technique can help us reconstruct the whole MR image from undersampled case-based data. Sometimes long MRI scan time can increase motion artifacts from patient movement. And because the scan time of MRI is closely related with phase encoding process in case space, and we also very hard to let patient don't make any motion for such a long time. So researchers proposed the undersampling case-based data and reconstruct whole MRI image with deep learning method. And this figure is research of Hyun et al. Did MRI reconstruction with deep learning method in 2018, and we can see deep learning model increase the earliest image clarity remarkably. But deep learning method applications in medical image, like many other methods, also have some problems that we need to consider. The first one would happen when the radiologist use this deep learning method for real medical decision-making process. Like this sentence, it is said by Nikita Stepanos in 2018. And this example mean that when we actually use this DR model in real world, some radiologists who are not very familiar with deep learning would think this kind of a prediction is very dangerous to directly use in medical decision making. And the second problem is limited labeled data of MR imaging. The main reason that deep learning can have better performance than simple machine learning model is because of deeper hidden layers. And with many hidden layers, deep learning model can extract more detailed features than other models. So it can make better performance than others. However, it also means that deep learning model has more weights that we need to train, like this left figure. And also, that's why deep learning model work very well in big data size situation. So recently, some institutes like Human Connectome Project are trying to solve this problem with make big data set of brain MR imaging, but it still isn't very enough. So for solving the problems of deep learning applications in MR imaging, what we can do in future studies. Firstly, for solving the real-world medical decision-making problem, I suggest that we can change the purpose of DR model from direct decision-making or prediction to help radiologists with providing useful information to let them make a medical decision better. And secondly, in my view, one of very important future direction of deep learning and medical image studies, especially the MR image studies, is uh, developing MR image data augmentation. Some of researchers maintain that it is the time that we need to think about how to use unsupervised learning skills in MR image analysis. It is very reasonable idea because many of us already know the example of gaming AI algorithm named AlphaGo outperformed other models, even professional human. But the problem is, as I said before, the number of MR image data is limited and so hard to train unsupervised model very efficiently. And that's why I consider studying about data augmentation and data generator skills is important future direction. Is my today's presentation, and thank you for listening.
Thank you, Jae-geum. And next panelist Asaduddin Muhammad will introduce about the real industrial examples about deep learning and medical imaging.
Hello, everybody. My name is Asaduddin Muhammad. I'm from Professor Song Park's studying in PhD course. So today I am your panelist too, talking about the adaptation of deep learning in medical imaging.
Asad, can you speak the mic more closely?
Okay. So today I'm going to talk about the adaptation of deep learning in medical imaging industry. So the adaptation of deep learning are motivated by reasons, as you can see here. Firstly, image analysis and diagnosis can be repetitive and exhausting for the physician or the radiologist. Their work includes annotating lesions or nodules, tumor localizations, and therapy or surgical planning. Their performance as a human is also significantly slower compared to the machine. So the automated system would perform much faster and without any exhaustion. Lastly, the amount of data that are available as an image in medical industries are abundant. There are about 90% of all medical data that are images. And there are simply not enough experts to deal with all of them up until now. So up until these days, with the emerging progress in artificial intelligence, there are up to or more than 40 companies developing deep learning methods for medical imaging. And among those, about 5 companies are based in South Korea. So South Korea's companies applying deep learning into medical imaging that I want to talk about today is Unit and Ers Medical. So firstly, let's talk about Lunit. Lunit is founded by KAIST graduates in 2013. They are offering AI-based medical imaging analysis, and their product works on X-ray or mammograph image and also microscopy for a different type. So they, up until now, they have achieved top 5 social impacts AI startup, which is awarded by NVIDIA in 2017. They are also Digital Health 150, categorized by CB Insights in 2019. And recently, they are considered as one of 100 technology pioneers by World Economic Forum. You can actually try their products in their website. If you upload your own data into the website, then you can see the diagnoses that are given by their own AI-driven products. So in this website, you can try the chest X-ray annotating application or mammograph annotating application. So here are some data that they presented. So here on the left column, you can see the result from chest X-ray images. The top case shows detection of subsegmental atelectasis in both lungs, and the bottom image shows pneumoperitoneum under the right diaphragm. And also for their mammography result, you can see that the detection of dense tissue that are considered as cancer tissue with a calculated malignancy score of 98% and 58%. Now, moving on, I want to talk about more MRI-related company, which is BiS987 Medical, founded in 2018, and their focus is in MRI image reconstruction, quality assessment, enhancement, and sequence optimization. And because they are new, the achievements that I could find is only this one of the 40 innovative companies awarded by the 2020 Unicorn Project. So their product, they only have one product up until now, and it's an AI solution for MRI reconstruction. They combine three techniques: deep learning, compressed sensing, and MRI physics. And using those techniques, they can halve the scan time, and their result is robust for many different body parts. Their application is also applicable to many different scanners and many different parameters, sequence, or organs. And they're also integrated seamlessly into the currently existing scanner application. So you can see on the right figure, the comparison between their before reconstruction and after AI reconstruction. So the left part is shown as the before reconstruction, and the right part shows after AI reconstruction. And you can see also that they worked for both brain and prostate. So to summarize, South Korea is actually one of the pioneer in deep learning adaptation for medical imaging processes. The automation in medical fields are really needed because of the increased amount of data, and overworked experts is not capable enough to work with all of the data available. So deep learning can open a path to faster and automated diagnosis process. However, the obstacle, as stated by Jagan, by panelist one earlier, is that they have to balance their accuracy and explainability, and they are also have to be accountable to any issues with the diagnosis result of their applications or of their AI products. And they also have to somehow gain the patient's trust through many different testings. So thank you for listening to my presentation, and back to your moderator.
Okay, thank you, Asad. This is the end of our presentation, and if you have any questions, please send the chat on the Zoom chat window.
So if you don't have any questions, then I'll give you some questions. So based on the review of your some companies in AI medical companies in Korea, what do you think is the future direction of the potential company if we want to found? If you want to found a new company, what would be the competing edges?
So I think for CT and X-ray images, there are many companies that explore those areas. But for MRI images, there are not many applications using MRI-based images. So working on similar area with Airs Medical or improving on them, so not only acceleration, but also maybe classification will be more, will also be profitable.
But that's also still, there's one company available. But also another thing is actually MR cases, usually those kind of things tightly coupled with the systems, right?
Yes.
In that case is how do you want to survive as a independent company from GE, Siemens, or Philips?
I think Airs Medical also talk about how they can apply their company, their application into different scanners and coils and parameters. So just robust testing would be into making sure that our company is their own performance.
Anyway, by the way, your actual speakers is on and off actually sometimes. Yeah. Microphone.
Okay. But did you hear my answer?
Yeah, a little bit. I'm not sure about other students. Any other questions from the students or maybe even among the panelists and the organizers? I think you should make this one live, right? And moderators and panelists, you need to look at the chat board and Q&A board to see whether there's questions, right? If you see the question, please read it so that everybody can hear, and then maybe some of you can answer the questions.
Okay, there's one question. Are there any possibility of that AI distort the original information so that it causes troubles in diagnosis? So if any presenters can answer this question.
I think it's very hard to say because even though AI deep learning skills accuracy is very high, but it's still in the level of 90% degree, 80 or 90% degree. So, so I think it maybe like the things I presented, like undersampled risk construction, undersampled data, this kind of model, I think it still have some probability that cause troubles in diagnosis if we use this research directly.
And you need to also look at the Q&A board as well.
Yeah, Hamaja questioned about how can legislation be done to address potential ethical issues related to AI applications?
So I think for in terms of rules that can be addressed, that can be done to address potential ethical issues. Firstly, we need to hold accountable the people that make the AI applications, and then for any misdiagnosis, then they should be able to explain what happened to the why the diagnosis could have been wrong. Therefore, using those informations, they could have update their system or provide explanation that are accountability related to any misdiagnosis.
And there's next question. I heard that it is hard to collect the medical data from human. What do you think about to use the data from other organisms, such as mouse, to learn the physics of modalities and applying to human?
I may answer the question. I think it is kind of good idea, and it is possible, but strict evaluation on the radiologist or other doctors are required.
Okay, if there is no more questions, and that's it for today's session 5. Thank you for your attention.
Okay, thank you very much for the nice talk. And so we'll meet you again after midterm, right? So, okay. See you then. Bye.